Good evening, everyone. Today I'll be presenting a review of a fascinating paper titled Deep Reasoning Translation via Reinforcement Learning, which introduces a model called DeepTrans. This work is done by a few authors who I've mentioned below, and it explores how we can teach AI to just not translate words, but also truly understand and convey the meaning by learning to think before it translates. We'll delve into how Trans uses cutting-edge techniques like reinforcement learning to tackle the complex art of free translation. So I've named my presentation Deep Trans AI that learns to think before it translates, and it is presented by me, Apurva Karne. So let's go to the next slide. So as you can see, what exactly is free translation? It is about going beyond a simple dictionary lookup. It is the ability to translate the intended meaning, complete with all its current subtitles, literary styles, and also the author's true intent. This is incredibly challenging for AI because it requires understanding things like metaphors, idioms, humor, and unspoken context, like things even humans can find tricky. And traditional machine learning translation often struggles here, giving us literal translations that can be awkward or miss the point entirely, especially with creative or literary texts. So it is hard, and there are a few limitations of the traditional machine learning translation. That is why we have this project. So the paper we're looking at here, it's deep reasoning translation via reinforcement learning. It introduces a model called DeepTrans. The core idea behind the DeepTrans is to enable large language models to perform deep multi-step reasoning before they actually generate a translation. So how it achieves this is primarily through reinforcement learning. And a key feature is this structured output. The model first generates an explicit thought process and then only it provides the final translation. So I would say that the thinking step, that is what it sets apart from all the other models. So as you can see, the core idea, the methodology is reinforcement learning, and this is the output structure, like think, generate a thought process, and then we get the final translation. So the key components, so under the hood, like DeepTrans is built on Qwen 2.57b instruct model as it is the foundation. So for the learning process, it uses an RL algorithm called GRPO, but the real innovation is the reward model that uses. DeepTrans also uses another powerful LLM called DeepSeek version 3. So DeepSeek version 3, it acts as an intelligent judge, so evaluating the quality of both the thought process and the final translation. So as you can see, like the reward model is there, and then the reinforcement learning algorithm is the GRPO, which is nothing but generalized proximal policy optimization. And the Gwen 2.57b instruct is an already existing LLM, which is really good, and you should check it out. And then this is the overview of the deep trans learning, as you can see. Um, the first sentence goes to the model and then it thinks the thought process, and at every process there is a reward. uh, like we already talked about how we uses reward modeling. So in every step there's a reward, and based on that we get the final translation. So LLM as a judge concept is central to DeepTrans. By using DeepSeek version 3 to evaluate its own outputs, DeepTrans can learn and improve without needing a massive data set, I would say, of a like we don't need a massive translation of a perfect human translation for every example. So instead of that, it just learns from the source text and the feedback or the reward that it gets. The reward, it's broken down into three parts. The format reward, which checks if the output structure is correct. Second is the thought reward, which is nothing but it assesses the depth and the quality of the reasoning process. And then in the end, we have a translation reward where DeepSeek V3 scores the actual translation on a 100-point scale for like let's say the parameters of translation like the fluency and the accuracy. So these are then combined into an overall reward that guides the model learning. So we have three different rewards: R format, or thought, R trans, and then after that we have the R all. As you can see, R all is nothing but it's a combination of R format, R thought, and R trans. So as you can see, the advantage is like without label target translation, but just by using reward modeling, it achieves like good accuracy without proper data sets. So the training for the deep trans happens in two main phases. First, there is something called as a cold start SFT, supervised fine tuning, and then after that, this is like a relatively quick and primarily it aims to like get the base LLM used to generating text in that specific like think then translate format using some general data. Um, the real learning, I would say, it happens in the phase two, which is nothing but the reinforcement learning training. This is much more intensive and it is where the model refines its thinking and translation abilities using the smart reward system that we discussed. Working with text from actual domain, it's being trained for, let's say, like we have an example, like let's like using literature in literature or something like that. So this is like the more interesting or the more important phase, I would say. Yeah, these are the two phases, the SFT and then the RL. SFT is nothing but it's a quick phase, whereas the RL it's like an intensive phase where the actual translation happens. And then so like let's talk about one thing, like does this approach work? The paper presents strong results, particularly on the metaphor trans dataset. Metaphor trans dataset, it's nothing but like it's a dataset which has uh, metaphors and their translations. It is quite challenging as it is like full of literary devices. And they used advanced metrics like GEFI, which aligns well with human judgments of literary quality. And then also DeepTrans 7B showed a significant 16.3% improvement on GEFI compared to the base model. It also outperformed other models that were trained using more traditional supervised methods on synthesized data. And also this 7 billion parameter model achieved like very competitive performance with like much larger models. So yeah, it does work is what I would say. The researchers like they also shared some interesting dynamics from the training process. For example, the average length of the thought that the model generated over time initially dropped significantly, perhaps as the model focused on getting the translation part right, but then the thought length started to increase again. So this suggests that the model learned that while like very short thoughts might be quick, they weren't leading to the best reasoning or the best final translations. So it found a better balance. So like initially there's a decrease and then there is like an increase. So that is why we can see that this graph, the thought length increases uh, as time passes. And then another fascinating observation was that what the authors termed as the stylization phenomenon. So what this is it is like around an intermediate point in the training, the model started to translate text into very distinct classical Chinese literary style. This happened why? Because DeepSeek V3, which was used as the AI judge, was giving high scores to this style. Maybe that is because of the data that it was performed on, it was learned on. However, the deep trans model, through continued reinforcement learning and exploration, often like managed to move beyond the specific style to find more broadly applicable ways to achieve high quality translations. This really highlights how dynamic RL can be and the subtle ways reward models can influence outcomes. So this paper also includes failure experiences or ablation studies, which show what doesn't work. So one critical finding was that about the thought reward. So when they tried removing the reward from generating a good thought process, the model like either stopped thinking altogether or it forced to produce some thought. Like it just came up with generic useless phrases. So the big takeaway here is that the complex behaviors like deep reasoning just don't appear on their own. They need to be like explicitly encouraged and rewarded. So like meaningful context specific reasoning does not emerge automatically. It does require explicit positive reward and guidance. And another vital lesson came from the experimenting with the scale of the translation reward. So the original model used a 100-point scale. When they tried much coarser scales, like maybe reducing it to just 3 points, then what happened was the performance suffered, and the model actually got stuck in that classical stylization phase that we talked about. So the reward signal just wasn't detailed enough to like guide it to better alternatives. So like a more fine-grained, wider reward scope is crucial. It gives the model more information to work with, helping it to like explore different strategies and also avoid getting trapped in like less ideal situations. So it is required for us to give like a more grained reward scope rather than a coarser scale. So to summarize the main contributions of this work, first the DeepTrans introduces a novel reinforcement learning methodology, specifically for enhancing free translation. Particularly, the use of an LLM to judge both the thought process and the final output is a very good thing. Secondly, they provide strong empirical evidence that this approach is highly effective, achieving excellent results even with like relatively moderately sized and learning only from the source sentences in the reinforcement learning stage. And third, I would say that the paper like shares its journey, including the failure experiences, so that even if someone is trying to recreate or trying to learn more, they would have an idea of what is working and what is not. So this in turn like provides deep insights into what makes the complex systems work. And then the significance of deep trans extends just beyond like translation, I would say. It offers a path towards more nuanced and culturally intelligent AI. A key impact is its potential to like reduce our reliance on massive, expensive label data sets. Because using RL, we can just work on small data sets, or using reward modeling, we can get away with like nominal data sets. So it shows how a LLM can judge and reinforcement learning can work from source text alone. The methodology itself, this idea of like defining desired behaviors and using an AI to like check the quality, could be a blueprint for many other complex AI tasks that require like both reasoning and generation. So, and we can also say that the uh, reward engineering that we used, or like how carefully these feedback systems are designed, it is very important that these also exist in the becoming of AI and in the development further. In summary, I would like to conclude by saying that deep trans represents a really significant advance in like teaching AI to do more than just convert words. It teaches the it teaches it to the reason like it teaches a way for it to be better, more nuanced and free translation. Its reinforcement learning framework, especially like the innovative use of LLM as a sophisticated judge, proves to be both powerful and relatively data efficient for the core learning phase. The detailed exploration of what works and what doesn't in the reward design like provides invaluable lessons for anyone working with these large models, as they can take this as their benchmark and they can build on top of it, and avoiding all of the things that they should all of the ablations, I would say, that do not work in this case. And ultimately, approaches like deep trans are paving the way for AI that is not only like more intelligent, but also more context aware. And as I previously mentioned, that AI will become more culturally aware and attuned in its communication. So yeah. Uh, this concludes my review of the paper, and thank you for your attention. And yeah, I have attached my Medium article as a link. You can find it on my Slideshare. That I'll have it in my description. And I am Apurva Karne. Thank you.